by the opposite operation. If it's square root of 3 minus 2, I'm going to multiply by the square root of 3 plus 2. Square root of 2. But what I do in the denominator, I must what? I must also do in the numerator. Okay, let's focus on the denominator first. This is just like this problem. One's plus, one's minus. So what did I say? We really don't even need to worry about outer and inner terms. We do need to worry about what, though? First times first. What's the square root of 3 times the square root of 3?
Square root of 9.
Square root of 9, which is 3. And last times last, square root of 4, which is 2, and this is minus. And in the numerator, if you distribute a 1 to that stuff, what do you get? You get that stuff. And so now all you have to do is clean it up. What's your denominator? Do you have to put something over 1? No, you don't have to put something over 1. So you could simply say the square root of 3 plus the square root of 2. Okay? Yes?
So you only do that whenever you have a radical in the denominator that can't be added or subtracted?
Whenever there's a radical in the denominator and it's being added or subtracted to something, that's when you do this.
But it's not the same. It's not the same.
Right. Okay? Or if it's just two completely different things. Suppose we had this. Suppose we had x divided by 1 plus the square root of 3. Or let's not say x. Should be writing in pencil. This should not be an issue. Let's say 2. 2 divided by 1 plus the square root of 3. Now, to simply multiply by the square root of 3 is not enough. Because even though it will eliminate the radical here, it will just create another one here. So what can I multiply by in order to get my goal accomplished? 1 minus the square root of 3. And as you do this more and more, you won't even have to work out all these steps because you're going to know that 1 times 1 is 1 minus 3 is negative 2. Okay, but I'm going to write it out because I see confused looks on faces. All right. First times first was 1. Your outer and inner terms are going to cancel. Last times last is negative square root of 9, which is negative 3. Now in the numerator, don't put it back together. Just leave it like that. Okay? And you'll see why in a second. What's 1 minus 3? Can I reduce the 2 that's outside with the 2 that's underneath? You remember our factoring? Where we said you pull out a greatest common factor because you can only cancel things that either are individually by themselves or entire groups. See, now we're taking that back into consideration. What do these cancel down to? Negative 1, all right? Which means it's negative 1 times this stuff or this. If these cancel to give me negative 1, I will distribute that negative in order to get this final answer. Okay? So the two new things we talked about today were the exponential exponent. No. Fractional exponents, right? A to the 1/2 is the same thing as square root of A to the first power. B to the 2/3 is the same thing as cubed root of B squared. Okay? So it's simply a matter of knowing that this goes here under the root, and then b is being squared. All right? And then you follow your radical rules. And then we up.
Yeah, what's that called?
This is called rationalizing the denominator. Rationalizing the denominator. Which means get the radical out from under the denominator. Okay? Let's do another one. Let's see if you can do it on your own. Clint, can you come up to the board and work it, please? That's all right. Come on. Have a little faith. You threw your pen down like you were confident. You didn't have to call it. Raise your hands on the side of it. Put equal sign in your hands. Good job. Very good. Check your work. Is that what you got? We started off with something in the denominator that won't go away by simply multiplying by a square root of 2. So we're going to rationalize it by multiplying, instead of the difference of those two numbers, the sum. And that's based off what concept? The difference of perfect squares. Okay? Because we know that that middle term goes away. What you do in the denominator, you must also do in the numerator, and then he finished it off. Good job. Okay, for homework over the weekend, I want you guys to do, on page 254, numbers 43 through 48, and then, yes, there's 6 problems. And then on page 261, (21 through 39 odd). And that'll give you practice on the fractional exponents.
Is that 19?
And working with them. This is assignment number 19. Okay, remember the test will be Tuesday. We'll review Monday. Tuesday, your binders will be due. So Monday, I've got to get all your homework assignments back to you so you can get them all straight.
So this is the last homework.